Hi there, my name's Jordan Stochevsky. I'm 23 years old and I'm the team leader of Quanteyes. Now, Quanteyes aims to build a logo detection system specifically for detecting motorcycle brands. The way we do this is running a two-stage inference pipeline built with YOLO. We then integrated this inference pipeline into a digital asset management system, which will help social media managers have a more productive job. This will reduce time to find content, as well as curate and manage content that comes from all over the world.
Firstly, we upload all of our photos via our online upload form into an S3 bucket. Once these images are inside of S3, we move on to the first stage of our vision pipeline, which is performing inference on the images with YOLO to detect motorcycles in the images. Once the motorcycles have been detected and cropped, the images are sent back to S3 and stored. Next, we use CVAT, manually annotate and validate the detected motorcycles and their logos. These annotated images are then exported back into S3. SageMaker then pulls the data from S3 to train our machine learning model. The model undergoes training and testing to ensure its accuracy and efficiency in identifying motorcycle logos. After the model is trained and tested, it is exported and imported into AWS Lambda, where it serves as our inference engine. During inference, any uploaded images are saved into S3 in our database. Lambda runs the inference to identify specific logos and other relevant details in the images. The detected labels are then updated in the media record, making the information available to the user. This streamlined process enables users to easily sort through images of motorcycles and identify specific logos.
As the amount of content data grows every day and searching for specific content, for example using tagging, has become a widespread necessity. Efficient assignment of tags to media content pieces is of high demand, and automation of this large-scale job is the goal of our project. Using computer vision, we first detect larger objects, for example motorcycles, and then we detect smaller features of those objects, for example motorcycle logos. Even though our project currently focuses on motorcycle logos only, due to the necessity to narrow the scope of the project to fit in our requirements, our project can be extended in the future to detect other objects and their corresponding features. Both for motorcycle and logo detection, we use YOLO V8 model, but future extensions might require using or adding other computer vision models in order to detect new categories of objects and their features. Lastly, integration into ClearML is planned for the nearest future to automate the deployment pipeline.
So this is our front end upload form built with React. And firstly, what users are going to do is they're going to upload all their content, so all their images, videos, to our backend. So here I'm going to start filling in all the data, like so. Email, there's some validation on these fields. We're going to select a city. We can also have some photographer credit. We can consent, and that'll open the upload form. After that, we can start uploading our images, which will upload to our S3 bucket. So you can see that's all successfully uploaded. We can click upload. There we go, there's a success message. We close that. And now what I'm going to do is I'm going to go into the view for admins. So this is how the admins are going to interact with the content. So here's the album that just got uploaded. And if I go into the albums and I search for a specific tag, such as Triumph, which is the brand of motorcycle that has been predicted, it should bring up some albums that have Triumphs within them. So say if we click into this album, we can see the first photo here, the first few actually, all have that Triumph brand. And that is the whole system.